Hi everyone, welcome to SharkAI. My name is Chandan Shashwat, and this tutorial we are going to talk about the general concepts of machine learning. So let's get started. So what is machine learning? So machine learning is an application of AI that enables system to learn and improve from experience without being explicitly programmed. Machine learning focuses on developing computer programs that can access data and use it to learn for themselves. So these are basically the programs. When we train those programs, then it can generate data for you. It can generate as well as it can classify the data and it can cluster the data for you. So like our human brains, it works in the same way. When we see something, we can recognize it. Okay, we when we are touching something, then we can say, okay, it's a hard or it's a soft. So the same thing it works for the machine learning. If it had seen it previously, what kind of things it is, then it can classify or generate or cluster. So it works same how our brain works in the machine learning. Okay, now machine learning, we classify the machine learning task into two way. One is called as the supervised learning, another one is called as unsupervised learning. So supervised learning, where we provide the data, historical data, and we train our model. So let's say, yeah, let's say that I have a elephant. I'm just representing elephant with E, and I have tiger with T. So I have this elephant, and you can say elephant and tiger, and then we have labeled it. Okay, so these are images: elephant image, tiger image, then elephant, and we have given the names of it. Elephant, this is tiger, this is elephant, and this is tiger. So these are images and these are their names. Okay, and when we are training this, okay, then what the machine learning will do, it will recognize the pattern. Okay, this kind of thing looks like elephant. Okay, elephant, and this looks like tiger. Okay, so tiger has some different feature, elephant has some different features. Okay, so it will learn the feature and it will label. Okay, this kind of feature, it looks like a elephant, this kind of feature, it looks like a tiger. Okay, and based on this, when you provide an image and ask how this image looks like, then it will, based on that patterns, it will tell you that it looks like elephant or it looks like a tiger. Okay, so this is called the supervised learning. Supervised, why? Because we have given them a training. We train them with this image and their respective labels. Okay, so this is supervised learning. Now you have something like elephant, tiger, elephant, tiger, elephant, tiger. Okay, so and you have not labeled, that means you have not told to your program that this is elephant and this is tiger. Okay, and this is elephant and this is tiger. You have not given this information to your program. So what and you, when I'm saying that recognize what kind of animals are there, then based on the feature it will just try to find out the uh, f- uh, find out though, or just try to cluster the animals. So based on the elephant features, it will cluster it. Based on tiger, it will tiger, but it will not able to tell you that this is tiger or this is elephant, means because we have not given label. Okay, it, you have to define, okay, yeah, this is elephant, it looks like, and this is looks like a tiger. Okay, so this is the difference. Here we provide the training data and the label. Here we do not have any labels, we only uh, provide the images or only provide the data. Okay, so this is the supervised learning and this is the unsupervised learning. Now the terminologies I am explaining in this video, because throughout this tutorial we are going to hear all these things: supervised, unsupervised, machine learning. And now in the same way, we have a parametric model, parametric and non-parametric. Okay, non-parametric models. So parametric models are where you have some parameters. So y is equals to mx plus c. Okay, so this is the equation here, and by our learning we decide what is the value of m and what is the value of c. So these are called the parameters. So because since it has a equation and it has a parameter, so it is called a parametric model. Some models are there where you do not have a equation, okay, like tree models. So those are called the non-parametric model. Always remember this: parametric model and non-parametric model. And right after this we will see the linear regression, and where I will explain you this MC and everything related to this. Okay, so now we will learn about the parameter and hyperparameter. So these are just the terminology. So remember this. Okay, these are not very important, but yeah, for data science perspective, you should know all these things. Okay, so now the parameters, and second is hyperparameters. So as you have seen in the equation mx plus c, when we train our model will find this value of m and will try to find this value of c. Okay, so these are called parameters which get trains when we train the model. Okay, and some parameters which we have to provide from outside. So if I see plus and alpha x, okay, so this alpha is actually a learning rate. I will explain you this later, but some of the parameters we have to provide from the from our own, okay, from our knowledge, or from some search helps, okay, which we will talk later. But yeah, these are the parameters which provided by the users are called hyperparameters. Okay, and this play a very important role in the data science, hyperparameters. Okay, so now another terminology is discriminative and generative. Discriminative and generative model. Okay, so what is discriminative model? So a discriminative model is, suppose you have an axis, you have some point here, okay, and you have minus minus some point here. When we are drawing a line, okay, I can classify that, okay, this is x, uh, this side of the line is x and this side of the line is minus. Okay, so this is called a discriminative model which distinguishes between the data or among the data is called the discriminative model. Generative model is, suppose you have this and you have some points like this, okay, some points like this, and I just try to plot a line like this. So my line is like this. So at any instance, if I have this equation, that suppose this equation is uh, mx square plus mx plus c, something like this. So any point of time, if I will provide you the value of x, you can provide the value of y. Okay, so I will tell you to generate some other points, then you can generate at any point because you have the equation. But if I will tell you to generate some points here, exact points, so you will not be able to generate here. Okay, but the exact point you will be able to generate because your line is going through your every point or nearly equals to every point. So this is called a generative model where you can generate the data. Okay, discriminative model is where you are distinguish between or among the data. Okay, so now let's talk about the machine learning life cycle, how it is. So here we have, first we have to set the objective, what is the business objective, and then it goes to data gathering. Okay, then it go to data preparation, okay, then it go to exploratory data analysis, say it EDA, then it go to model building, then it go to model evaluation, then it comes to model deployment. Okay, so this is the complete life cycle of a machine learning project, and let's talk about the different stages. So objective is what we are going to achieve here. We are going to classify something. Our target is to classify something, or to generate some data, or to cluster some data. So what is our objective? Okay, now it comes to the data gathering. So data gathering from uh, the source system. What is your source system? Can be like SQL, Mongo, can be like your simple Excel sheet or CSV. Okay, so data source can be anything from where you can connect to your Python and get the data, or sometime explicitly we get the data through the Excel or CSV. Most of the time we get from the Excel or CSV. Then data preparation. So here you have to do this missing value treatments. Okay, then uh, duplicate records, remove the duplicate records, and okay, so these kind of things we do. Now it comes to the EDA, the main part where you are going to spend your most of the time working as a data scientist. So you have to do this visualization. Okay, what my data is saying. Now sometimes statistical analysis. Okay, not for every objective, but yeah, we have to do. Then the outlier treatment, then we have to do data transformation. Okay, standardization, or Z transformation. We have many data transformation techniques, so we will talk about all those. And then we have to select the feature selection. So all the columns are not important, so the columns which are important, how to extract them. Then if you have a categorical values, then how to deal with them. Okay, then if you have a imbalanced data, how to deal with that imbalanced data. So likewise we have many scenario based on the algorithm to algorithm, it varies. Okay, because some algorithms, they do take care of outliers, they do take care of missing values. Okay, so based on algorithm to algorithm, your EDA varies. Okay, now the model building is select your model. Okay, regression model, classification model, and based on that you decide your algorithm. It is a decision tree, or a linear regression, or something else. Okay, now it comes to the data evaluation is like we do using the confusion metrics. Okay, most of the time. Okay, precision, recall, F1 score, precision, recall, F1 score. Okay, so, and if it is a for this is for classification. If you have a regression model, then R2 score, RMSE, uh, and then clustering we have Silhouette scores for finding the clusters, and then we have to evaluate. Okay, now the model deployment. So deployment, where you are deploying your model. you are deploying to the Linux environment or Windows. Okay, and after the deployment, okay, so here in the deployment many things comes like uh, how the APIs you are creating. You created your model, but in the deployment, the only your model is not going to work. So you have to create the APIs using this. So how will you create using the Django or Flask API? And then you have to how do you take care of the predictions? So predictions it will come via the Django or go to the model, predict, and return it back to the returning back to the source which is requesting for this. So this is model deployment. So yeah, this is the whole or the complete life cycle of machine learning projects. And yeah, in this tutorial, uh, as we go on, we will see each and everything. Okay, whatever I have experience working as a data scientist, I'll try to cover everything. Yeah. So now let's talk about the missing value treatment. Okay. So this is the common issue you are going to face in your data set most of the time, that the how to deal with it now. So suppose you have a column. Okay, suppose you have a column 1 where most of your data is not available. Okay, so you can say that most 90% of your data is not available. Okay, so you can drop this column because this is not going to participate in the in creation of your model. Okay, even 80% of data is missing, you can drop. So based on your experience, when you will grow in the data science, you will get an idea then when to drop this column and when to not. But yeah, general assumption is, yeah, more than 80-90% of data is missing, then we can drop that column. Okay, now this is the column 1, but suppose if some value is missing in the row. Okay, suppose I have C2 and then column 3. So some values are missing in 3. Okay, some values are missing in 2. So here it is missing in 2, here it is missing in 1. So few values are missing in the column. So dropping the row, entire row, will not be a good idea because you are going to lose the information about this C1 and C2. Okay, now the challenge is keeping this value and how to replace or how to impute this value C3. Okay, so as you remember that when I was teaching the statistics, I taught you about this mean, median, and mode. Okay, so when you draw C3, okay, and when you see it's a perfect Gaussian distribution, then your mean, median, and mode will be here only. So if this is continuous value, okay, I'm talking about the continuous value, not the categorical value. So what is categorical value? That also I have explained you in the statistics. So if it is a continuous value and it's a perfect Gaussian distribution, then you can replace it with the any one of this, mean or median. Mode will not be applicable for continuous value. Okay, so you can replace with mean or median. Now the problem comes when it is not a perfect Gaussian distribution. Suppose it is right skewed. Okay, so, yeah. Okay, a little bit right skewed. Okay, so then where will be your mean, median, and mode? So if you remember, when I was teaching that, I told you that in the right distribution, here will be your mode and here it will be your median and here will be your mean. So you can see uh, as it is right skewed, so most of my data right skewed means most of my data will be in this side. So substituting with the mean will not be a good option, so always go with the median. Okay, because mode value is also, you can see that if you see the distribution, you can see the data, this is actually not your middle point of the data. Okay, so where it comes here in the median value. Same applies for the left skewed. So whenever it is left skewed or right skewed, always go with the median, okay, not with the mean or mode. Okay, it's a continuous value, then definitely mode doesn't come. But yeah, not with the mean. Okay, mean can give you a wrong information, because if one data is 1000 and your other data is like 1 2 3 4 something like this, then because of this you are getting this as a right skewed, and your uh, mean can be towards the 1000, but actually it should have been here. Okay, so if it's a right skewed or left skewed, substitute with median. Okay, now this was about the continuous value. When it is the categorical value, then mode, substitute it with the mode, the most frequent, the values which are available in this column will get substituted. So this is all about your missing value treatment using the mean, median and mode. Another methods are also there, like KNN and deep learning. So KNN is also an algorithm. KNN is K nearest neighbor. We will talk about this when we talk about the clustering and KNN. So this is also a way of classification, but I will explain this later. And another one is using the deep learning. Okay, so this deep learning I will explain when I will be teaching you the NLP or CV or the deep learning. Then I will be explaining you this. So right now we have these three methods, and basically we don't follow this unless we have very less data. Okay, most of the time this works. Okay, so now we are going to see about the outliers. So if you have not watched my statistics video, please do watch, because in the statistics I have explained everything about the outliers. I have even explained the z-scores, z-transformation, and then Gaussian distribution, the skewness, box plot, and everything. So using all those techniques, I'm going to show here how to detect the outliers, okay, and how to treat them. Okay, so let's start. So I will give you an overview, because there are so many techniques for outlier detection. So I will give you an overview, but don't worry, uh, as we will go ahead with the algorithms, and if we need in the some data set to data transformation or the outlier treatment using these techniques, I will definitely do. But yeah, the most important what I am going to explain here is the z-score. Okay, other things as the session or as the tutorial will go ahead, and I will explain you with the real examples, then definitely I'll go ahead with everything. I will explain you everything. Okay, so now the first technique is called the g-score. Okay, let me write z z-score. The second one is local outlier factor. Okay, local outlier factor. Okay, the third one is angle based detection. Based detection. I don't have practice of writing this, so excuse me if I'm writing too bad. Angle based detection, and then depth based technique. Then it comes isolation forest. Then it comes autoencoders. Okay, and here it comes db scan. Okay, so these are the, as far as I know, these are the outlier detection technique, and maybe some other will also be there. So let's talk about the z-score. So I have a Gaussian distribution. Okay, and as I have explained that within the one standard deviation we cover 68% of data, within the 2 standard deviation we cover 95%, and within the 3 standard deviation we cover 99.7% of data, okay, approximately. So after the 3 standard deviation, okay, anything comes after 3 standard deviation, we will take it as an outlier, okay. Anything after the 3 standard deviation, anything comes, we will take it as outlier, okay. And if you have detected something outlier, what to do now? So you have find out one outlier. So if it's a continuous value, then we are going to replace it with median, as I have explained you, median, okay. We will replace it with the median, okay. And second one is local outlier factor. So local outlier factor is uh, we have some points here, okay. We have some points. So basically we see the density about how many data points are surrounded here, and we try to find the density. So if the density is higher, then it is the chances are more that this is surrounded by the similar data points, or it is not an outlier. But if some point is here, then you can see that it has no density, or you can say if another point is here, then these 2 points has the low density, okay. So you can say that these are outliers based on the density, okay. The third one is angle based detection, okay. Let me show that. So let's say angle based. So I have some point here, okay, and I have a point here. So let's consider these 2 points, and okay, we'll just try to angle here and angle to here, okay. So further points, the furthest point have a low angle, okay. It will create a low angle, but the points which are nearer will create a higher angle, okay. So this is called the angle based detection. If the angle is low, okay, then it will be more chances that it will be an outlier. If the angle is more, then it is the chances that the points are not an outlier. And based on your data or the angle which we are getting the maximum, you can decide that whether it is an outlier or not, okay. Another one is called the depth based technique, okay. Depth based technique is you have several data points, okay. You have like this, this. So what we do, we just try to draw a line like this, and then if the points are here, we are drawing here. If the point is here, we are drawing here. So these are the depth, okay. This is the second depth, third depth, fourth depth. So we can say that if this is basically used for the clustering. So you can see that if the furthest points are outside, okay, then you can say that these points are outlier. So these, okay, these points, this depth is actually called an outlier, and we will remove all the points. So this is called depth based technique, okay. And this is mostly used in clustering techniques, okay. Now it comes to the isolation forest. So isolation forest is like when we are dividing the data set, okay. Actually isolation forest I will explain you, but it's hard to explain now. Isolation forest is also very much used in credit card fraud detection. So whenever somebody is doing the credit card fraud, then by using this we can determine that if the transaction is a fraud or not. So I'll just try. So any data set, if we are creating a tree, we cut the data set, okay. We cut into the first cut, you can say that I have cut the data set in 2 parts, like this. This is the first cut. Then I have cut the second data set this in the second cut, okay, like this. And when I did the third cut, suppose here the third cut, and I'm after the third cut, I'm getting my most of the point here, okay, and this is my fourth cut, okay, and I'm getting 1 point here, 1 point here, and 1 point here. So these are basically called your outliers. After the when we grow the tree, and when after 1 2 cut or after 1 2 division, if my data points started going in isolation, then these points are called outliers, okay. And most of the points, the genuine points will last uh, go till the last of the tree. So this one I will explain you because this is hard to understand now, okay. So another one is autoencoder. So this is a deep learning technique. So we have something called encoders, and we have something called decoders, okay. Okay, so when we encode something, and from the encoding we try to decode something, then wherever the wherever the reconstruction loss is more, we call it as outlier, okay. Whenever the reconstruction loss is more, it is called an outlier, okay. So this is autoencoder. Now let's talk about db scan, okay. db scan. So db scan is, suppose you have some points, okay, and you have given a length of suppose 3 centimeter. So within the 3 centimeter, if you are finding, if you have given, if you are finding 3, then we are okay. If you are finding less than 3, then we are not okay. This is outlier. So this is, you can set, okay, 3 centimeter, this is the length you can mention. And from this point, if you are getting 3 points, then okay, more than 3 points is okay, otherwise it is now outlier. So when it will reach to the outlier in 3 centimeter, it will not have anything, okay. So it will be considered as an outliers, okay. So this is the whole idea about outliers, yeah. But we will discuss in the linear regression more about the z-score, okay. And wherever it is needed in the algorithms, when we go to the logistics tree and everything, then whatever will be needed in the algorithm, we will adopt that and we'll work on that, okay. I'll show you, yeah. I forgot to explain you about the outlier detection using IQR. So let's discuss this now. Outlier detection using IQR. So in stats, I have already explained you what is IQR, interquartile ranges. So Q3 minus Q1 is our IQR. I explained you what is Q3 and what is Q1 in statistics. So the outlier will be anything Q1 minus 1.5, 1.5 and IQR, and Q3 plus 1.5 IQR. So if you have a plot like this, Gaussian distribution, and my suppose Q3 is here, Q1 is here, so 1.5, and this is called as IQR. So 1.5 minus IQR, and it will be somewhere here, Q3 plus 1.5 IQR. So anything beyond this and anything beyond this will be our outliers. So this is the technique we use for outlier detection, and the same thing we plot in the box plot also. So here will be your median, this is your q3, this is your q1. Okay, then you can see somewhere in this line only q3 plus 1.5 IQR, and this is IQR. I explained you in the box plot in statistics, and q1 minus 1.5 IQR. Yeah, so this is one of the technique for outlier detection which we are going to use. G score and IQR, these are the two techniques for continuous values which most of the time we use. Yeah, now let's talk about the encoding techniques. So we have seen how to deal with the continuous values, how to find the outliers of them. So now let's see how to encode the categorical values. Categorical values, we have several techniques. Why we are converting? Because some algorithms, they don't understand the categorical value, so we have to convert it with uh, the numbers like 0, 1, 2, 3, 4. So, and categorical value has some also problem. We will see in the algorithm what is the problem. So it depends on the algorithm to algorithm. So I will explain when I'll deal with the algorithms. So first is called label encoding. Okay, label encoding is, suppose you have name 1, name 2, name 1, name 3, and name 4, and name 2. So label encoding is, you can okay, you can name the name 1 as 1, name 2 as 2, then name 1 will be 1, name 3 as 3, name 4 as 4, then name 2 will be 2. So we have assigned one number to the names. Okay, so these are called the label encoding. Okay, ordinal encoding is you have something like cold and warm and hot. So you can arrange it like 1, 2, 3. Okay, this is in order, so you can always place this in order. That's why it's called the ordinal encoding. Okay, ordinal encoding. You can order these things like the person who is coming first, second, third in race, you can arrange them. So these are the ordinal encoding. The third one is called the frequency encoding. Okay, frequency, that means how many times uh, the number 1 is occurring. So suppose here how many values are there? 1, 2, 3, 4, 5, 6. And how many times 2 is occurring? 2 times. So 2 divided by 6. Okay, so this is your frequency encoding. Frequency encoding. 2 divided by 6. Number 2, how many times it is occurring? 2. So it will also be 2 by 6. 1, since 1 is, so 2 by 6. 3 is occurring only 1, so 1 by 6, 1 by 6, and this will be 2 by 6. Okay, so this is frequency encoding. Another thing is target encoding. Okay, target encoding. So target encoding, how many times this 1 is there? 1 and 2. So suppose in the target, this is I'm writing here, suppose we have some target, name 1 is 1, 0. 1 is like you can say he is maybe, some values like pass, fail, or something. So here also 1, 0, 1, 0. As we have already seen in the pandas tutorial that he has heart disease or not. So here we have only one column, so it's difficult to rate. But if you have more than one columns with the name, with the age, BP and all, he had something or not. So based on this, we have suppose this. So frequency encoding is take the mean of it. So name one is uh, how many times it is that 2, and suppose you have, so we cannot right now here, suppose you have something, some numerical values, okay, uh, that 40 or name to 60 and 40. So basically we will take the mean of it, like this is 60 and this is 40. So we will encode it as a mean of that particular group. That means name one and name one, how many times it is that? So 40 plus 60, 100 divided by 2. So it will be 50 and 50. Okay. Similarly, name 2 is 60 and name 2, suppose here it is 30. So it will be 30 plus 60 divided by 2, since it is occurring 2 times. So 30 plus 60, 90, 90 by 2. That means 45. 45 will be here and 45 will be here. Okay. The values we replace by the mean of the value, mean of the group value. Okay. So this name one and name one is forming a group of similar names, and then we are replacing the values with the mean of it. Okay. This, so that's why it is called as frequency encoding. Another one is called binary encoding. Binary encoding. So suppose you have a city like Chennai, and you have Bangalore, you have Delhi. So in the column you can write Chennai as 1 1, Bangalore as 0 1, and Delhi as 1 0. Okay. So this is your binary encoding, and some other cities also there. Hyderabad, then it will be 0 0. Okay. So this is binary encoding, and there is something called one hot encoding. So one hot encoding is, if you have same thing Chennai, you have Chennai, okay, Bangalore, Delhi, and Hyderabad. So we will create another column for Chennai. Okay, Chennai underscore 0. Here it will be Bangalore underscore 0. So that's how it got created. And for Chennai it will be 1, Bangalore will be 0, Delhi will be 0, and Hyderabad will be 0. For Bangalore it will be 1 here, rest of else will be 0. For Delhi it will be 1 is 0 0, it will be 1 here and 0. Hyderabad it will be 0 0 0 and 1. So this is your one hot encoding. But one hot encoding give you a lot of features. So suppose you have thousands of features, okay, and where you have a 10 to 15 categorical feature, and when you convert all these to one hot encoding, it will give you a lot of columns. So that is called the curse of dimensionality. That means we are adding more dimension to the data. Okay, so how to deal with these things we will see in the algorithms. Okay, so now let's talk about the feature scaling. Feature scaling. So feature scaling is a technique of converting the features into the same scale. Suppose you have one column between 1 to 10 and another column where the value ranges from 100 to 100k. Okay, in this case some of the algorithm which uses the distance, so you can say that the distance will be dominating this feature over this feature. That's why we always want to scale our feature in the same scale. Okay. In the distance based algorithms like linear regression or SVM. So when you have so how many types of feature scaling we have? First one is like min max scaler. Okay. Mean max scalar, the formula is x minus x minimum divided by x max minus x minimum. Okay, so you have the value of x, you have the minimum value, you have the maximum value minus the minimum value in that column. So this is mean max scalar. Scalar. Another one is normalization. So the here x minus, in the place of x minimum, we just differentiate with x mean divided by x max minus x minimum. Okay, and the last one is standard scalar, standardization, that is x minus x mean by standard deviation. Okay, so these are the formula, but you should always remember it should not have an outlier. Okay, these two scalars, because if you have outlier, then this value will be too I mean it will be too much. Okay, this value. So always remember that in the standard scalar, that is okay of having outlier, it will remove. But here you should not have it. Okay, so let's talk about bias variance trade-off. Okay, so bias variance trade-off. Okay, so prior to this, we should know what is bias and what is variance. So variance I have explained you a lot in the statistics. So if you have not watched that video, please do watch that variance video. But this is the variability of the data. And bias in machine learning is a sort of mistake in which some aspects of data sets are given more weight than others. Okay, suppose you have to pick one shirt, okay, out of 10 shirts, and you like the red color more. So what will you do? You'll select the red color. So this is called the biasness towards something. Okay, so our model has also some biasness. So how to deal with it? Okay, so let's talk about bias variance trade-off. Okay, so the formula for total error is equals to bias square plus variance plus irreducible error. So when we try to plot it, so variance will go something like this, and bias square will go something like this. Bias square variance, so our total error will be swinging like this. Okay, this one. So and this side it is the model complexity, and this side error. Okay, so if I take this point, okay, so you can see if I will take this point, my bias is at lowest but my variance is high. Okay, if I take this point, then my variance is low but my bias is very high. Okay, so I cannot take these points. Okay, so what point should I take? So as I can see, they are intersecting here. Okay, and this is the point which I should consider, and where our actually this line should pass from here. So where our bias and variance are at minimum. Okay, so this will give us the generalized model. Okay, so what happens when we have a high variance? Okay, so if we have a high variance, model tries to memorize each point in the training data, and when you will train it, what it will do, it will go through the each points. Okay, it will go through the each points, and it will try to memorize the data. And uh, when you do with the test set, it will not perform. Okay, so this is called overfitting. So it is overfitting our model, and this is high variance case. Okay, when I talk about high bias, so what will do high bias? So suppose I have some points here. So our model will behave something like this. So it will be poor on the training data as well as on the test data. So bias pays lot of attention to the training data and oversimplifies the model. So it will perform poor on both the data, training data as well as the test data. Okay. And so this is your overfitting and this is your underfitting case. So uh, how to remove this overfitting and underfitting is, uh, overfitting you can reduce model complexity. Okay, reduce model complexity. Then you can do the early stopping. So early stopping is a deep learning concept. I will tell you when we will be talking about deep learning. And regularization. So right after this we'll talk about the linear regression and I'll tell you the regularization techniques. And dropouts is also a deep learning concept. I'll explain you that. So these are the some concepts for when your model is overfitting, then what to do, and if your model is underfitting, then what to do. Increase training samples, increase feature complexity, increase features, increase model complexity, and remove noise. So these are some concepts if your model is underfitting. Okay, so this is how you deal with this is how it is, the bias variance trade-off. Okay, so now let's talk about the confusion matrix. So this is a way of evaluation of your model, classification model. So your classification model is how much accurate and what your actual values are and what your model is saying. So this is the way of evaluation, confusion matrix. Okay, confusion matrix. So as the name said, it is a confusion matrix. So it is actually a confusing thing. So let's see. So these are the actual values. Okay, what we are giving to the model, and these are the predicted values which we are getting from the model. So you can say that this is true positive. True positive is actual value is also true and predicted value is also true. Okay, actual value is pregnant and model is also predicting at pregnant. So this is true positive. True negative or false negative is when my model is saying it is not pregnant and actually it is not pregnant. Okay, so my value, it's saying it is not and predicting is also not. So this is false negative. Okay, now the error states are when my actually this guy is not pregnant but my model is saying that he is pregnant. So this is called a type 1 error, false positive. Okay, type 1 error. And actually this lady is pregnant but my model is saying she is not pregnant. So this is called the false negative, and this is a type 2 error. Okay, type 1 and type 2 errors. So sometimes in the interview they will ask you what is type 1 and type 2 errors. Okay, so this is type 1, actually not pregnant but predicted as pregnant. Here also actually it is pregnant but the model is saying it is not pregnant. So this is the false negative. So if you draw a confusion matrix, so you can draw like this. Okay, here your actual values. Okay, and this is predicted values. Let's draw like this. And suppose this is positive, this is negative, and this is your positive, this is negative, this is true positive, this is false positive, this is false negative, and this is true negative. So this is type 1 error and this is type 2 error. Positive predicted as positive. Okay, so this is true positive, and negative predicted as negative is true negative. Okay, and negative predicted as positive is false positive, and positive predicted as negative is false negative, type 2 error. Okay, now here comes what is your precision recall and F1 score. So precision is your true positive divided by true positive plus false positive. Okay, recall is true positive divided by true positive plus false negative. Okay, and you can say your F1 score is actually your harmonic mean between the precision and the recall. Okay, and accuracy is true positive by true positive plus true negative divided by this all. Okay, true positive plus false negative plus true negative. Okay, so this is your accuracy. And what are these two, precision and recall? So precision is of all positive predictions, how many are positive? Okay, so this is your precision. Recall is of all real positive cases, how many are predicted positive? So this is the recall. So recall is actually important when you are predicting something. Suppose there is an example like a terrorist is trying to enter into the airport and there is a scanner. Okay, and your machine learning model is actually a scanner and it is trying to predict the terrorist. So how many times you are correctly predicting terrorist as a terrorist? So terrorist is important for us. Okay, you cannot let any terrorist go inside the airport. Okay, so in that cases where the positives are more important, we will give it as recall, and we will try to increase the recall, because even if you misclassify one terrorist, it is going to be the worst case. So you cannot allow any of the terrorist. So in that cases recall is important. And the precision is how many times you are able to identify the terrorist. Okay, so the recall is when you, how many times you are correctly identifying the terrorist as a terrorist, and precision is how many times you are able to identify the terrorist. Okay, so this is precision, this is recall. And there is something called F1 score, that is 2 into precision into recall divided by precision plus recall. So this is actually your harmonic mean between the precision and recall. So what is the use of it? Okay, suppose one model is giving me precision value and the recall value. Okay, and I just want to increase the value of precision. Okay, so I have increased the value of precision and my F1 score is drastically went down. Okay, so this is actually a harmonic mean. When you are doing it, it should not be drastically increased or decreased. Okay, when you are increasing the recall, it should be a harmonic mean. Okay, it should not be it should not be drastically increase or decrease when you are doing something with the precision and the recall. Okay, always remember this. And then it comes accuracy. So accuracy is your true positive, true negative, and divide by the uh, true positive, false negative, and true negative. So this will give you the accuracy of your model. Yeah. So now we are going to see how to select the important features for the model. How to select important features. Okay, so the first method is remove constant features. Okay, constant features. So what is constant feature? So suppose there is a column 1 where all the values are 1. Okay, okay, so we already know for the model variance is a important factor and there should be a variance. Okay, so if there is no variance, this is no use of the model. Okay, so we are going to drop this. Okay, so this is called the removing constant features. Another one is remove quasi-constant features. Quasi-constant features. What is that? So if there is a little bit of variance, suppose all the values are 1 and only one value is 2. So there is a variance, but that is very less. Okay, and you can see that you can set a threshold. Okay, suppose you can set anything, 3, 4, 5, any threshold you set. If above this the column is passing this threshold, then we are going to take, otherwise no. So likewise, you can detect if the variance is there for model to understand or not. Okay, based on this you can drop the column. For in this case, if you have thousands of records and only one record has another value, then you can definitely drop. Okay. Third one is select k-based. Select k-based. So it uses the chi-square. Okay, and you can pass how many number of features you want, and that many number of important feature it will return you. We'll see this one. Okay, and then another thing is ANOVA. So ANOVA is also used for selecting the features, important features. Fifth one is correlation. So correlation we talked a lot in the statistics. Okay, so by using the correlation also we can select the important features, or we can drop the features which are correlated. Okay, the sixth one is random forest. So random forest we will see in depth. Okay, and how it works in feature detection of important feature selection, that will also we'll see in the random forest. But yeah, for the now you should also know that random forest is also used for feature selection. Okay, another is lasso. So when we will see the linear regression next, after this we'll see the lasso. So lasso is also used for feature selection. So how it works as a feature selection we'll see in the linear regression. Okay, so these are the feature selection techniques which I know. Maybe a little bit more will be there, but which I am not aware. But yeah, as I know, these many features are there. These many things are there to select the features, important features. Yeah. Thank you for watching my video. And next topic we will start as a linear regression.